Chapter 1 of Artificial Fluency by Carlos E. Welcome, everybody. Get ready for a deep dive. Today, we're going to explore signs and symbols and how they shape meaning. We're going to be looking at Chapter 1 of Artificial Fluency, a book by Carlos E. Perez. It's packed with some thought-provoking stuff. So get ready to see the world and AI in a whole new light.
It's really fascinating how even simple signs can lead to such deep insights.
Okay, so I'm hooked already, but let's break it down. For those of us who aren't, semiotics experts, what exactly are E-signs? I mean, is it just like a fancy word for symbol?
It's a bit more than that. A symbol is a type of sign, but it's more complex. A sign you see is anything that represents something else. The key is it makes you think of something. It triggers like an interpretation. That's where Charles Sanders Peirce comes in. He's like the OG of semiotics.
Right, so lay some of that Peirce wisdom on us.
So Peirce came up with this brilliant model, the Triadic model. It says that any sign has three parts: the sign itself, the object it represents, and the interpretant.
The interpretant, okay.
Yeah, and that last part, that's where the magic happens. It's the meaning that we create in our minds when we encounter a sign.
So it's not just a simple, like, this equals that kind of thing. There's more going on in our brains.
Absolutely. Meaning isn't just sitting out there waiting for us to find it. It's something we actively build through interpretation. Like, let's say you see a footprint in the sand, the footprint itself. That's the sign. The object is the person. Or, well, whoever made it. And the interpretant, well, that depends.
On the person seeing the footprint.
Yeah. It could be, someone walked here recently. I wonder who it was. Or even, maybe I should follow these tracks.
Oh, I see. It's kind of like how the same word can have different meanings, depending on who's saying it, or even the context.
Exactly. Peirce's model helps us understand how communication works, but it also helps us understand how AI is being developed. Peirce didn't just stop at 3, though. He went on to describe 10 different types of genuine signs. He combined icons, indexes, and symbols in different ways to get a richer understanding of information.
Whoa, 10 types. Okay, my brain is definitely tingling now. But before we go down that road, can you remind us the difference between those 3, iconic, indexical, and symbolic? I always get those mixed up.
It's easy to do. So an iconic sign, it's all about resemblance. Think of a photograph of a cat. The photo looks like the cat, right? That visual likeness is what makes it iconic.
So a realistic painting would also be iconic.
You got it. Even a cartoon cat, if it's recognizable, as long as it has the key features. Now, indexical signs, they're different. They have a direct connection to the object. Think smoke and fire. You see smoke, you know there's a fire somewhere. The smoke is an index of the fire.
Oh, like a thermometer. The mercury rising shows you how hot it is.
Exactly. Or a doctor diagnosing an illness based on symptoms. Those symptoms are indexes, pointing to a specific condition.
Interesting. Okay, what about the last type?
Symbolic signs, those are the tricky ones. Because the meaning is completely conventional. There's no inherent connection or resemblance, like words, a great example. The word tree doesn't sound or look anything like a tree.
Right.
But we all agree it means that tall, leafy thing.
So things like traffic signs, logos, even gestures like a thumbs up, those are all symbolic.
You got it. And here's the really interesting part. These categories can overlap, like that photo of a cat. It's both iconic because it resembles the cat, and indexical because it captures the light reflected from that cat, this layering of meaning. It's really important when we start talking about how AI systems trying to make sense of the world.
Okay. That's making me think differently about even everyday things, like photos. Like there's this whole other level of meaning we usually don't even think about it.
And that's what semiotics is all about. It helps us unpack the hidden ways we create meaning in human communication and in AI systems.
Okay, so this is where things get really interesting. How do all these types of signs and that triadic model connect to AI? Especially these powerful transformer models we hear so much about.
Well, it's all about how these systems process information and make inferences. Transformers, with their self-attention mechanisms, are doing something amazing. They're connecting different parts of a sequence, sort of like our brains do when we read or listen to a story.
So it's not just processing words one after the other. It's about understanding relationships in context.
Right. Like in the sentence, the cat chased the mouse, but it got away. We understand that it refers to the mouse, even though the words are separated.
Ah, I see.
And that ability to connect the dots and make inferences based on the relationships, that sets transformers apart. from the earlier models of AI. It's like they're starting to use a more sophisticated kind of reasoning, closer to what we do.
So transformers are kind of like kids, semiotic sleuths. They're figuring out clues and connections to understand meaning.
That's a great way to put it. They're learning to interpret signs in a more nuanced way, which is a huge step towards AI that can truly understand language and the world around us.
This is amazing. We're just scratching the surface here, but I feel like I'm already seeing the world and AI in a whole new light.
It's amazing how powerful these semiotic tools can be. And believe it or not, we've only just begun. Perez had a lot more to say about science, and understanding his ideas can help us understand AI even better, both its potential A and D limitations.
Well, my brain is ready for more. Let's take a quick pause to let all this sink in, and then we'll be back to dive even deeper into this fascinating world of semiotics and AI.
Welcome back. Before the break, we were starting to see how all this semiotic stuff connects to AI.
It's wild, the idea that transformers are like little semiotic detectives, piecing clues together to understand the world.
Yeah, it really shows you how complex these models are. And there's another piece to this puzzle, Perez's concept of inferences.
Inferences, isn't that just like a fancy word for conclusions?
Well, it's a bit more nuanced than that. Think back to how we use signs to think and reason. Different types of signs lead to different types of inferences.
Okay, I'm listening. Break it down for me.
So let's start with iconic reasoning. It's when we use analogies and mental images to make connections. Think about it. You're trying to solve a problem. Maybe you remember a similar situation you've dealt with before.
Like, I'm trying to fix, like, a leaky faucet.
Yeah.
Maybe I think back to, oh, that time I patched a hole in my bike tire. Both involve stopping something from leaking, so
Yeah.
maybe there's a similar principle there.
Exactly. Or think about how we use mental pictures. To understand abstract ideas, that's a form of iconic reasoning, using visual representations to grasp something that we can't actually see.
So iconic reasoning is all about making connections based on resemblance or shared properties.
Exactly. Now, indexical reasoning, that's more about cause and effect. It's like being a detective, looking for clues, tracing back from the effect to its cause.
Oh, I see. Like a doctor diagnosing a patient based on their symptoms. Those symptoms are like indexes pointing to a certain illness.
Exactly. Or how we learn from our own experiences. You touch a hot stove, you get burned. You quickly figure out hot stoves cause pain. That's an indexical inference.
Makes sense. Okay, what about the last one? Symbolic reasoning. That one always trips me up.
Right. Symbolic reasoning, it's all about language and math, social cues, anything where the meaning is based on rules, on conventions we agree on. It's the most abstract type of reasoning because the link between the sign and the object is completely arbitrary.
So like if I say the cat sat on the mat, you understand that sentence because
Okay.
we both know English grammar
Yeah.
and what those words mean.
Exactly. There's no real connection between the sounds we make and the idea of a cat sitting on a mat. But we all agree on this system of symbols, so we can talk about all sorts of complex ideas.
Wow, it's amazing. So are our brains constantly flipping between these different types of reasoning without us even realizing it?
Our brains are incredible. They can integrate all those modes of reasoning. Think about how you make sense of a tricky situation. You might use visual cues, remember past experiences, analyze what people are saying, all at once. It's like a seamless mix of iconic, indexical, and symbolic processes.
Okay, that makes me wonder, how does this all relate to AI? Especially those transformer models. Can they use all three types of reasoning?
That's the big question. Researchers are still trying to figure that out. The main approach in AI now, especially deep learning, it relies a lot on recognizing patterns. That's more like iconic reasoning. But transformers, with their ability to connect the dots, make inferences from relationships between words, they seem to be tapping into. That's even symbolic reasoning, at least a little bit.
So they're not just matching patterns, they're actually starting to understand the relationships and make conclusions.
It seems that way, which is really exciting because it means these models, they're moving beyond just imitating human language to actually understanding it on a deeper level.
That's a huge step. How is that even possible? I mean, how can a machine, even a fancy one, grasp something as abstract as meaning?
Well, that's where we get to the idea of code duality, a really interesting concept. From biology, think about DNA. It's like a code, instructions for building an organism. But the DNA itself, it's just a molecule. It needs something to interpret it. Cellular machinery to create meaning.
I see where you're going with this.
Yeah.
You're saying the parameters of a transformer are like the code, the raw data, and the architecture of the transformer. It's like the interpreter making sense of that code.
Exactly. The parameters are like the script, and the architecture is the actor, bringing that script to life. And this dual nature, it lets transformers go beyond just mimicking patterns. They can actually generate new text that's relevant to the context, just like our cells interpret DNA to build and maintain our bodies.
So they're not just spitting out what they've learned.
Yeah.
They're using it to create something new. That's incredible.
It is. And this brings us to another exciting development, diffusion models.
More models. My brain is about to overload.
Don't worry, this one's super cool. Diffusion models are pretty new, especially for image generation. Imagine being able to create a picture just by describing it with words.
Wait a minute. Like if I say a fluffy white cat sitting on a windowsill, watching birds fly by, the AI would create an image that matches that description.
Exactly. And that's what diffusion models do. By using code duality, they start with just noise. Then they gradually refine it, guided by the words you give them, until a clear image appears. It's like starting with a blank canvas and slowly adding details until you have a masterpiece.
So it's like the AI is thinking in images, translating words into something visual.
You got it. The key is that the process itself, the gradual refining, guided by the interpretation, that's where the meaning comes from.
This is seriously impressive. We've come a long way. From simple signs to complex reasoning, to AI that can make pictures from words. It's like we're seeing how meaning is made.
And that's the power of semiotics. It gives us this framework to understand not just how we communicate, but also this rapidly changing world of AI. And really, we're just getting started.
My brain needs a break. Let's pause for a second to digest all this new info. We'll be right back to unpack what this all means. For you, our listeners, we've just scratched the surface of semiotics and, well, I'm already seeing connections everywhere.
Right. It's amazing when you start thinking about, signs and how we interpret things, you realize how important those processes are for understanding the world.
Okay, but let's make this a little more practical for a minute. Why should all this matter to our listeners? What's the takeaway from understanding semiotics? Especially now, with all this AI stuff happening.
That's the key question. This isn't just some theoretical stuff. It has real implications. For one thing, understanding how semiotics works in AI makes us better consumers of all this AI-generated content.
So we shouldn't just, take everything an AI tells us at face value.
Exactly. Remember, these AI systems, they're trained on huge amounts of data. And those data sets, they can have biases, inaccuracies, limited perspectives. But if we understand how AI interprets and creates meaning, we can spot those limitations and ask the right questions.
Like, where did this information come from? What are the biases built into the system? Are there other ways to interpret this?
Exactly. It's all about being a little skeptical, recognizing that AI is powerful, but it's still a tool made by humans, reflecting our limitations and perspectives.
So critical thinking is key. What else?
This is where it gets really exciting. When we get semiotics, we can see the amazing potential of AI to help us be more creative.
So we're not just talking about AI replacing artists and writers.
Right. It's way more nuanced than that. Think of AI as a partner, a brainstorming buddy, helping you see things differently, come up with new ideas, push your creative boundaries.
Like how some musicians are using AI to make new sounds or explore new genres.
Exactly. Or writers using AI to get over writer's block, experiment with different styles, even co-create entire stories. The key is using AI to expand what we can do creatively.
I like that. Instead of fearing AI, we can use it to help us express ourselves better.
That's the spirit. And finally, this might be the most important part. Exploring semiotics makes us think harder about what intelligence really is.
Okay, tell me more.
For ages, we've defined intelligence based on how humans think, logic, reason, language. But AI is turning all that upside down. AI can do stuff we thought only humans could do. But they do it differently. Their brains work differently than ours.
It's like we're meeting a new kind of intelligence. Alien, but it gets things done.
Right. And it raises some big questions. What does it mean to truly understand something? Do we need to change how we define intelligence to include these new ways AI thinks? Are we, in a way, more like these artificial fluent systems than we realize?
Those are some really deep thoughts. It's like the semiotics deep dive. It's not just about signs and symbols. It's about how we think.
That's the power of semiotics. It helps us understand AI, but also ourselves, our place in the world, and the potential of both human and artificial intelligence to shape the future.
Wow, we covered a lot of ground today. Pierce, transformers, even code duality. My brain feels like it's been through a workout.
It's been a wild ride, and the best part is, we're just getting started. There's so much more to discover in semiotics and AI. Keep exploring, asking questions, and pushing the boundaries of what you know.
If you're as fascinated by this as I am, you have to check out Chapter 1 of Artificial Fluency by Carlos E. Perez. It's a mind-blowing read. It'll change how you think about the world.
And remember, the real takeaway here isn't just the facts we talked about. It's about being curious. Keep exploring, keep questioning, and keep that semiotics lens handy as you navigate this amazing world of technology.
Happy exploring, everyone.